Okay, we are in a discussion of AWS Solutions Architect, and we've been discussing about EKS, Elastic Kubernetes Services. I discussed the elements of Kubernetes clusters in my previous video, and we're just going to continue discussing a little bit more about this component in a basic level. So today we're going to discuss a bit of a pod component, a deep dive, right? So as we compared this one with the modern smart building, right? Pods are pods can be one container or number of containers, right? So that means pod is like a smart building's a flow, right? So in the flow you have apartment, right? Few apartment in the floor. Pod can be a one apartment or pod can be a few apartment together, right? So in that saying, in that comparison, right? So pod structure is pod wrapper is a logical boundary containing container. So that is a logical boundary. So you like wrapping a container. That's think about a gift parcel. You wrap that boxes into there. So that is the boundary. And then you have a shared network namespace. Single IP for all containers. That is something similar. Let's say you in a one floor and you have few apartments like few units in there, and you're probably going to use elevator in that floor to go out from the building or coming into the building. So it's something like you sharing a common area, similar to like a single IP. If you have a few different containers, they using the single IP address for representing them for all containers, right? And then the same thing like shared storage volumes. They might have a sort of a common facility you can use. Like let's say you got a common facility in that flow. It's just like shared storage volumes. The shared storage volumes I just compared in my first video, like a university student, few university students renting one of the apartment, and then they shared their refrigerator space, so and kitchen, they sharing bathroom, something like that. So that's a persistent data access for all the containers, right? And then you have container types, main application, primary workload container, and then init containers, setup task before main containers, right? And then sidecar containers supporting services like login. So sidecar containers, I compared something in a motorcycle. You put a sort of another wheel, and you attach a sidecar. So it's a part of the container, and when you destroy container, the sidecar also will be destroyed. And then the infrastructure component, post container, maintenance network namespace. So you have one network namespace. The volume mounts, shared file system access, environment variables, and configuration injection. Networking config components is a pod IP, unique cluster wide address, whole cluster representing that address, and port mapping, container port exposure, and then DNS resolution, right? So if you're looking into this picture, you could see the ones I explained. So pod IP is a common single IP for the shared network namespace is 10.2.4.4.1.5 in example. And then is DNS is my app default SVC cluster.local. That is how you represent them. And then you get a pod wrapper like a boundary, and then you have host container and network namespace, and then you have main container like application container, and then you have site container, sidecar container, and then you have a shared volume, right? So that is how pod structure normally consists of, right? Main component. All right, EKS component detailed breakdown. So what do you have, right? So EKS component. So we spoke about pods, we spoke about container, and then AWS manage control plane where the orchestration and deployment, everything handles in this control plane. So API server, application programming interface server, IAM integration and authentication happens in there. ETCD is automated backup and encryption. That service is handled by ETCD, right? And scheduler, so multi availability zone, high availability, and then controller manager, AWS service integration. So other services will be integrated with the controller manager. So it's like S3 RDS and Lambda relational database system. So we spoke already, and the VPC network, native AWS networking, and then CloudWatch monitoring, integrated observability, troubleshooting, and then you have application load balancer and network load balancer support, ALB and NLB, and then customer manage worker node. So if you customer manage, so you can do Kubernetes, right? Node agent for port management and Kubernetes proxy, that network proxy for services, and then a container runtime, so Docker contain fusion, right? So you see the part of AWS EKS manage versus self-managed responsibilities, right? So what services are AWS managed and what services are customer managed in these clusters? So you could see infrastructure mainly upgrades, security patches, availability on deployment, control manager, scheduler, control plane. Everything was managed by AWS. But worker nodes contain a runtime, which application node security, right? Scaling and monitoring will be managed by customer mainly. So it's easy to set it up, and then you manage monitoring, scaling, node security, application container runtime, and worker nodes. Everything else will be automatically scaled, and infrastructure is provided from my AWS, right? All right, so EKS deployment strategies and best practice. So what is the best practice? Blue green zero downtime with the production and testing environment, and then canary, gradual traffic shift for risk mitigation, rolling updates, progressive replacement of code, so that you don't need to shut down. Um, so upgrades, updates, right? Node group configuration instead type mix of demand and spot. So that is a cost control. So you can use essential on-demand instances, and then if you have a sort of like a festival period or something, you got more traffic, you probably can use some spot instance for money saving strategy, scaling, cluster auto scale, and HPA, right? Pains and tolerations, workload isolated, the labels node FA. nitty rules, right? Cluster set of best practice, so multi-availability zones, so high availability across zones, private subnet for enhanced security posture, so version strategy, regular updates, setting, add-ons, core DNS, web proxy, CNI, right? VPC, CNI, and then I use security services like rollback, RBAC, role-based access control, and pod security standards and policies, and then network policies, and then you can use AWS Secret Manager for secret controlling. EKS deployment strategies comparison. There's a sort of you have the graph and picture reader comparison radar. So that says critical lab zero downtime required, right? So matrix rollback speed resource overhead, right? Sort of things you could see. So we can see other integrated services. So this is how we monitoring and logging CloudWatch, Container Insight for metrics, Prometheus custom metric collection, Fluent Bit log aggregations of Grafana dashboard visualization. So that is all for monitoring and logging, and then cost optimization, as I said earlier. So you could use spot instance if possible, and then right sizing, toy scaling, reserved capacity if you have a predictable workload, and then scalability, horizontal body scaling and vertical body scaling, event-driven scaling, and multi-cluster cross-region strategy for high availability and disaster recovery scenario. Okay, EKS, networking and security. So when you're considering, when you are providing these pods, how is going to be security levels apply. So it's basically VPC cloud is private cloud, and so you put them in a private subnet that giving you extra security, and then you can use security group. You can see in the picture security group applied to case control panel, APC server, TCD, and scheduler, and then all others can be integrated with the IAM, right? And then rollback policies, they're all integrated with this one. So that means you have a multi-layered security, right? EKS combined IAM with RBAC, comprehensive access control, your cluster resources as well as the private subnets. So there's no internet access, that's a VPC isolation, right? That's used to limit traffic between control plane component and within cluster, right? And then security group you can use, right? And then disable public access to use endpoints, and then private access enabling. So that is how secure wise it can be protected. EKS best practice for reliability, so high availability. So this is how do you want to do best practice for reliability of your application. So use high availability and scalability, right? Deploy multiple replicas of critical application to prevent single point of failure. Use replica sets or deployments to maintain desired port count. Implement a stateless architecture. So design applications to be stateless whenever possible, right? Allowing for easy scaling and adding more scales without infrastructure change. Configure stable network endpoint, right? stable IP address and DNS name for your application, ensuring they remain accessible even when underlying ports are replaced or moved. So group you can use uh, DNS name. It doesn't affect when the ports and other stuff moved, right? So EKS best practice for security, security first approach, right? Least privilege principle protect content rights, right? Applications or access control, right? So ensure AWS EKS cluster endpoint is public, isn't public. Restrict access using a security group that allowing incoming traffic only to port 443, right? And then you can use least privilege principle with IAM role-based access control, multi-factor authentication or tokenization access keys for enhanced security. Ensure core DNS added on version matches the EKS clusters Kubernetes version. Disable remote access to EKS cluster node groups to prevent unauthorized SSH RDP connection. Monitoring and encryption. So implement envelope encryption of Kubernetes secrets using Amazon KMS key management service. Ensure all Kubernetes API calls are logged using CloudTrail. So that will be logged due to auditing later, right? So cost management in EKS, right? So right sizing. So how do you manage the cost? So right sizing work node, select appropriate instance type on a workload requirement, avoid over provisioning and unnecessary cost. So right, so leverage this spot instance when you do have not enough on demand instances, right? And then implement auto scaling, right? Horizontal pod it auto scaling and cluster auto scaler to dynamically adjust to resource based and actual demand patterns, right? So instant type auto scaling is put instant resource request. So this is how you cost optimize, right? Uh, See that when you need it, just like example, right? Over the time, how do you manage? Like you can see the baseline, see that the baseline optimization, right sizing only, right? Spot instance only, right sizing plus spot instances. So that's how you manage your hosting, right? Alright, before we going to end this video, we're going to discuss about advanced EKS customization, right? So the areas you can customize, right? So you can do network architecture, uh, security controls, storage solutions, and operation tools. So description. So custom VPC configurations, subnet designs, and security group for work and all enhance security isolation compliance with organizational network policies. So that's your compliance with your network policy to optimize by the way your requirement for your organization. So security controls, integration with IAM roles, RPEC policies, and third-party security tools give you a chance to granular access control, improve threat detection and prevention. That's according to our organization need and a storage solution. So custom storage classes, persistence, volumes, configurations, and backup is strategy, right? Hmm. Custom monitoring logging, right? And optimize performance for specific workload, data protection, compliance. And operational tools, management tooling beyond the default EKS offerings, right? Better visibility, troubleshooting capabilities, and operational efficiency, right? So I believe that concludes our EKS, and we probably going to start a new topic on next week. Until then, thank you very much.